So this video here is to go over the basics of roof framing and rafters. So while you're watching this video and watching these slides, you should be filling out this note sheet here. It'll look a little different because you'll see something in this box here, but either way, this note sheet, Introduction to Rafters Notes Guide, you should be filling out this while we go through these slides. All right, so let's go back here. So roof framing definitions. So a gable, a house that has a gable is a house on one side that has a triangular wall enclosed by the sloping ends of the roof. So that's called a gable, this area right here. And then something basic from math that we use a lot, and that you'll see the shape here, half of this gable, it's a right triangle, a triangle connected using a 90-degree angle. All right, a rafter, so this is kind of like the underneath of this roof here. This is kind of what you would see. This is what's the framing, the supports are. So this angled board here, this framing member installed at a slope or an angle, this is a rafter. And then down here where it connects to the top plate, you see a little notch out right there. That's called a bird's mouth. It's an opening cut into the rafter to allow space for the double top plate. That's the second top plate that we don't do in class. They do on this site when they're actually putting it there. So that's a really important thing because that's a very technical cut that we're going to have to make when we do rafters. All right, this ridge beam, that's the highest horizontal roofing member. It aligns all rafters at the top end, one size bigger than the common rafter. So if your rafters are 2x6s, this will be a 2x8. If your rafters are 2x8s, this will be a 2x10, so on and so forth. So this horizontal thing that all the rafters tie into, that's your ridge beam. All right, one of the really important tools that we're going to be using when we're doing all of our layout and measurements is this thing called a framing square. We've used it once before. The important things for you to know is this smaller, kind of thinner end right here, that's the tongue. This larger, kind of thicker end here is the blade. All right, so types of roof. So you should sketch these out. So a very basic type of roof where it's two sloped sides and then two open sides that are like a triangular shape. This, and then on the back side you don't see right now. That's a gable roof. It's a very common style you'd see around. Something you see very often in the Chicago area is a hip roof. So it's angled on four sides. So there's no gables. It's just a hip roof. So it has four sloping sides, and they all meet at a center point or center ridge beam. You can have a gable with a valley. So if you have like your normal gable house right here, and then you have like a kind of wing coming off of it. So it's a gable and valley. So it has two intersecting gable roofs where they meet is a valley. So this area right here is a valley. So the way that house would look underneath of it, again, just kind of reiterating the ridge beam. So this is the roof framing members. So this part here and this part here would be called the ridge beam, the highest horizontal roofing member. Aligns all the rafters at the top end, and as we said earlier, is one size bigger than the common rafters. Common rafters, so all these in yellow here are common rafters. These are your full-length structural elements that go from the ridge beam down to and kind of past the double top plate. These are the ones that we're going to be building. These ones here in purple, we're not actually going to be making any of these, but it's a hip rafter. It's a shorter rafter, and that's because when you have your hip roof, your other slanted roof here, it kind of causes these rafters to be a little bit shorter. They can be called hip rafters or hip jacks. Yeah. All right, so this is going to be a very important image. I'm going to try to clear things up a little bit here so we can see all of it. So this is kind of like, looking at the end of a gable roof. We have the span. That is the the horizontal distance from the outside of one exterior wall to the outside of another. So like this is the outside edge of one wall, this is the outside edge of another wall. The total distance between the two of those is called the span. All right. The run is half the distance. So it's the outside edge of the wall to the center of the ridge beam. So the horizontal distance from the outside edge of one wall to the center line of the ridge beam, half the span. All right. So the run is half the span. The rise, that's the vertical distance from the second top plate up to the ridge beam. All right, so it's the total rise of the and it's always stated in inches per foot. All right, so the rise. It's not the total rise. It's just the rise. Slope. That's usually given as something 12, so 512, 712. It's the slope or the incline of the roof. The reason for the 512 or 712, the 12 always represents 12 inches or 1 foot. So it's always given in how much does it rise per foot of run. So you're going to hear that a lot, the rise per foot of run. And so what we need to do, the biggest calculation we're going to do is figuring out what the length of the common rafter is. So there's a process to do this. You're usually given the span, and once you're given the span, which is the outside edge of the wall to the outside edge of the other wall, you have to find the run by remembering that run is half of the span. You need to then figure out the unit rise per foot of run. That's when you look at the slope diagram. We'll show how to do this. Then you can use the framing square or do some math. It's your call which one you want to do. Obviously, if we're doing like this at home where we don't maybe have a framing square available to us, we would use a calculation. If you're in the classroom or on construction site, you have a framing square, you can actually just use the framing square, which has all this information kind of printed on it. And then to figure out the common rafter length, you multiply the common rafter length per foot of run by the number, essentially the number of runs, like by the amount of run to figure out the common rafter length. All right, so let's practice this. So for example, we have this situation here where we have a span of 20 feet and the slope is 812. So we should be able to figure out what the common rafter length is. So essentially, what is the length from here up to here with just this information? All right, so we're trying to figure out this distance from this edge up to this edge with just the information knowing what the span is and what the slope is. So given that the span is 20, we know that the run is half the span. So run is half the span, so half of 20 is 10 feet. So the run is 10 feet. All right, oops, that was not supposed to hide some of this, but something's not going quite right here. Either way, so again, knowing that the slope is 812, if you imagine not seeing this red part here, I just inverted. Try to go back here if I can. All right, so I just inverted this slope here, so it's 12 inches of run, 8 inches of rise. So rise per foot of run, for every 1 foot or 12 inches, it rises 8 inches. All right, that's where you get 8 inches. The rafter length per foot of run, again, this information, you could just look it up on the framing square, or this is a right triangle. You use the Pythagorean theorem, a squared plus b squared equals c squared, 12 squared plus 8 squared is c squared. You get 208 as c squared, taking the square root, you get 14.42. So 14.42 inches. Obviously, my sheet was not set up quite right. So go back here. So 14.42. My apologies for the mistake with the slides. But yeah, there you go. That's the answer. All right, so what's the common rafter length? You have 10 feet of run. And so that means that if you put 10 of those slope triangles together, where you have 12 inches and then 8 inches, which means a slope of 14.42, you have 14.42, 14.42, 14.42, you have 10 of them. And so 14.42 times 10 is 144.2 inches. That's the total length from this bottom edge to the top edge. There we have it. The common rafter length is 144.2 inches. All right. Once you know that, then you're going to actually have to do the layout on the rafter. And this right now we don't have the ability to do it in class, but when we get back to class, we will. But knowing the process is important. So first of all, obviously getting a piece of lumber that's the correct size. If there's a crown, meaning like any kind of like a curl or curve in it, make sure the crown is facing up. Mark the ridge plumb cut using the framing square. And again, we'll show you what that means. It's just important that you get this information down now. Measure the length of the rafter along the top edge using the number figure from the framing square table. Mark the plumb line for the bird's mouth. Again, just make sure you write this information down now, and that way we can have it available to us when we get back to class. All right, then it's the overhang amount from the bird's mouth plumb cut to the end of the 12 to the end. Sometimes it's 12 inches. Other times it can be like 16 or 8. Kind of depends on the house and the architect, whatever they wanted. Make a plumb line to the overhang mark. Again, the idea of a plumb line, you'll see what this all means later. Mark 1.5 inches from the bottom of that plumb line for the bird's mouth cut. Slide the framing square to the position for the seat cut mark. So you'll see again what this all means when you actually do it. So go back to the original plumb line for the ridge beam and cut 3/4 back to allow for half the thickness of the ridge beam. So again, we'll explain what this all means. Cut that line, cut the plumb line at the end of the overhang. Cut the bird's mouth using a circ saw or a handsaw. All right, and while you're doing all this layout, you have to make sure to use a framing square. The way you always use a framing square, the tongue will always be in your left hand, and that measures your rise. The blade will always be in your right hand. That always measures the run. When you lay out your lines, you go from left to right. You only ever use the outside edge numbers on the framing square. It's really important. If you do sometimes inside, sometimes outside, or vice versa, you're going to get yourself confused. So in this class, we always just prefer to make it standard, just use the outside. Use the bottom edge of the board for the rise and run numbers and the top edge for measuring. All right. And that's it. So this should help you get a baseline understanding of what to do. After this, we're going to practice doing some calculations so you know how to calculate all the measurements you need to actually do a rafter layout.